Okay, so what we're going to look at is we're going to solve simultaneous equations using matrices. So what does simultaneous equations mean? It means when you have more than one equation, but you see how we're using the same unknowns. So see how they both have x, y, and that? So what we're saying is we want to solve them. And what we're trying to find is we're trying to find what value of x and what value of y would make those statements true. So there's many ways you can solve simultaneous equations, and probably in the past some of you may have done it and some of you may not have. So we know those two equations there, they could actually be lines on a graph. So say this one, this could have been, might look like, say like that, and then say I had the other one, this one under here, and it might look like that, okay? So if you graphed it on an axis with, say, y and x, you don't need to worry too much about that. That's what it could be done. So when you're solving them simultaneously, what you're finding, that's the solution, yeah? So it'd have an x value and a y value. It'd be at that spot, yeah, that they equal, those two equations make sense. So that's what simultaneous equations are, and that's what we're trying to solve. We are going to use a matrices method to solve them, and you need to show all these steps in a minute. So I'm going to step you through it, and you remember you always have your notes, so you can just copy what we do with the notes. So here's what this is what you have in your booklets, and this is what we're going to do. So we saw before, here are my two equations. So we had a number that, here's the x, see, and there's the y, there's the x, and there's the y. So we had a number that was in front of, say, the x's. There was a number there before, and there was also a number in front of the y's, and then we had a answer of those equations. So first of all, what we've got to do is we have to set up these two, the equations they've given us, we've got to set it up in matrix form. So this is the setup in matrix form. So what you do, in this first matrix here, you're going to have all the numbers that were in front of the letter. So or say A was in front of X, B was in front of Y, C and D. It'll look like that, okay? In the next, then you're going to write its times. In this middle matrix, you'll write the letters that you're trying to find. So for us, it was X and Y. So we're going to put those red letters in there, X and Y. And then in the last one, we say we let it equal whatever it ended in, those equations. Okay, so this format is going to be used every time. So can you see down here, I've decided to call these matrix underneath, I'm calling this first one matrix A, and I'm calling the next one matrix X, and I called the end one matrix E. So what I'm showing you over here is I'm just showing you really what we would have. We'd have matrix A times matrix X, and it equals E. So if I had, for example, if I had an equation, if I had 2x equals 6, say for example, if you were trying to solve this, you would bring that 2 over the other side, wouldn't you? And because it's timesing, we divide, and then that's how you find out x is 3. Well, here's what we're trying to do. We don't know what this X matrix is. We don't know this one. So we want to solve, we want to work out that one. So what we would do is we want to work it out. So this is the solution. This is how we find the solution, the answer. We're going to times the inverse of this first matrix, this A one, by the end one. And so that's how we find it. So in a nutshell, when we go to do it in our calculator, we're going to write out the numbers again, wherever in that spot. Because the inverse, we'll raise it to the power of -1, and then we'll times it by those ending numbers. All right? So if I flick back to that that example at the start, and I'll do it with. So what I'm saying is, see how we've got these two simultaneous equations. If I want to set it up in matrix form, okay? So I set it up in matrix form, these equations. The first thing I'm going to do is, the first matrix is going to have all the numbers, so 3 and 2, and then the next equation, 5. Now this is like a number 1, yeah? Then I had to do times. Then I wrote the letters that we don't know. What are the letters we don't know? We don't know X and we don't know Y. Okay, the thing you just got to be careful with, this has to be all the X's down there and this has to be all the Y's so that it looks like that. Okay, then I said it was equal to the ending numbers, which is 12 and 13. So sometimes they'll ask you, set up those equations in matrix form. That's what you do. Now, if they ask you to solve those equations, what you're going to do is you're going to, it's this matrix, this 3, 2, 5 and 1. You've got to do the inverse of that one and you've got to times it by that other one, the 12 and 13. So what we're saying is this is what X and Y equals. So we'll get an answer when we put it in our calculator, and we'll be able to say the top answer is what X is and the bottom answer is what Y is. So I'll do it on the calc to show you. So in the calculator, all we're popping in is this bit into the calculator, yeah? And then it gives us the answer of 2 and 3. So therefore we know the answer. So you would write that out. Sometimes when we want you to do everything manually, we might get you to manually show me the inverse of that matrix first and then go. But you can always just do this last bit on the calculator. So I'm going to leave it there actually. Okay, so with this, we can sometimes have 3 equations where we don't know 3 things. So it would be the case where we have X, Y, and Z are our things that we don't know. So X, Y, and Z would be equal our unknowns, okay? And then you would have all these, and I've just used a letter to show you. So I would have all these numbers. So the blue bit would be the numbers in front of the letters. And then we would have, then we would have those equations also equaling something down here, okay? So what we would see if we had to, now be careful, you might want to write this, is set up. So if I had to write those equations out in matrix form, just like with the 2, all the numbers would go out in this first matrix, okay? And all the unknown letters would be in this little column matrix. And then what it equals would be in that last one. Okay, so that's how you would set up. If you're going to solve it, okay, if you're going to solve it, you're going to type this matrix, that for the first one, that would have all the numbers in it. If you need to solve it, you type that one in first and you'd raise it to the power because you need the inverse, and then you would times it by that one at the end. Okay, and this one you would never have to do manually, you just have to do it all on your calculator. Okay, all right, so let's do some examples, some more examples. So here's a nice 2-1 like we had before that we've practiced. So we've got 5, 2, 7 and 3. They're the numbers in front of the X and numbers in front of the Y. So we know we put X, Y in there. So we've got 5, 2, 7 and 3. And then remember what it equals goes in this one. Okay? So they might call it matrix representation, they might call it setup, whatever you want to call it. And we saw how we solve it. As I said, you just have to type this bit into your calculator. So you can see we're typing this matrix to the power of -1 and timesing it by that matrix, and then we get the answer. So really what this is telling us that x equals 5 and y equals -2. So that's what we're trying to find, what x and y is with these two equations. Okay, so down here we have an example of 3 unknowns. So first of all, I'm going to do the setup. Okay, so if I had to set this up in matrix form, what I first would have is, because there's 3 unknowns, there's actually x, y, and z, I will have a 3 by 3 here. Okay, so I'm putting all the numbers in front of the letters here. So x was 3, y is 4, and z is -2. In the second one, be careful, they've told me an x, so x is 2, y is 3. There's no z, so if there's no z, you put a 0. And then in the last one, remember, if it's x is like by itself, it's actually a 1, and then we have a 2, and then we have a 3. So that's our first one. Then we say times by x, y, z. So just remember, the order you put it across here has to be the order that goes down there. Okay, and then you got to do, equals, and we're going to put the end, what the equations equal. So it was -5, -1, and 3. Okay, if we're going to solve in our calculator, what we're going to do is it's going to be that first matrix that we wrote out there, the 3, 4, -2, this one. We're going to raise it to a negative power, so we'll raise it to -1, and we'll times it by that end matrix. So this is what we've got to type into the calculator. So I'm just going to pause the video here, and we're going to do this on our calculators. Okay, a manufacturer makes 2 sorts of orange flavoured chocolates, House Brand and Orange Delights. The number of kilograms of House Brand, X, and the number of kilograms of Orange Delights, Y, can be made from 80 kilograms of chocolate and 120 kilograms of orange filling can be found solving the following pairs of information. Okay, so there's a lot of blurb, and they're just saying that X, so just to make it a bit more of a summary, they're just saying X equals number of kilos of Orange Delight, and Y equals number of kilos of chocolate, yeah? Okay, so, oh no, was that the other round? This was House Brand. Number of kilos of House Brand and number of kilos of Orange Delight, okay? So they've asked us using matrix method to solve this. So I'm going to pause it here. I want you guys to go write up the setup, and then show me what you would use to solve it, and then solve, and then tell me how many kilos of each. Okay, so I have just popped in the answers here. So this was set up. So I put all the numbers in front of the letters into this matrix here. Then I said times x, y. Now, I just wanted to show you what I could do when I went to solve, what I've done here, and sometimes they ask you this. They ask you to find the inverse part first. So what I've done here is actually popped in that first matrix and raised it to -1 and pressed enter, and I got the answer. And so then I pop it in there. Sometimes they say, and they might do that, so they're going to do it little step by little step. And instead of going all in one go on your calculator, they do it step by step. So this matrix here is actually that inverse completed, yeah? So it's not just the raising it to the -1, they've actually done it. So just to show, you might want to pop that in your notes, just so you understand that they could ask, or they could put that like that, and then you might think it's wrong, but it's not wrong. Okay, so in the end, I found the answer was 100 and 100. So if they ask how many kilos, make sure you write an answer. So it was 100 kgs of house brand and 100 kgs of Orange Delight. Okay, it's okay if you abbreviate like that. That's okay, all right? We're not really asking you to write too much, but you need to understand what's what. So make sure you make a little statement there. Okay, question 6. A worker can assemble 10 bookcases and 4 desks in 360 minutes and 8 bookcases and 3 desks in 280 minutes. Each bookcase takes B minutes to assemble and each desk takes D minutes to assemble. The matrix BD will be given by. So what they're doing, they often give you, what they're doing is giving you simultaneous equations but in words. So B and D are our unknowns. So if you think about this is the first simultaneous equation said in words there. So I could write 10B plus 4D equals 360, and then they give me the next one, the next equation, and it is 8 bookcases plus 3 desks equals 280. Okay, so they've asked, if you were trying to find what they're asking, they're saying, what is that equal? So we know if we did setup, it would look like this. We'd have 10, 4, 8, 3 times B, D equals 360 and 280. But they want you to know, they want to know how you solve it. So how we solve it is normally we put this, we do the inverse and we times it by that N1. So how you solve it, this is one way of how we would solve it. So if you look through, is there any matrix, any like example there that's written it exactly like that? No. So what I suggest we might do is we're going to try and just find what that is, the inverse itself. So let's go do that on our calculator. So I'm going to pause it and you guys do it on. So we've popped this in the calculator and this is what this actually equals. So you're actually timesing that number, that matrix, by this matrix. So let's go have a look. So we look in and we can see A was the answer. That replicates that. Okay, so a basketball coach has written 3 linear equations which can be used to predict points, rebounds and assists on Oscar's next game. Okay, these equations can be written in matrix form and they've given you below. So what you have to do is along here, all the numbers that would be in front. So the first all have 1 in front of it. The next one has a 2, a -1, a 3, and this one's a 1, a 2, and a 1. Okay. It says down here, it says the matrix can be solved doing this. And then it says determine the value of x. So can you see this matrix here is actually the inverse done, yeah? So this is the inverse matrix already done. So you're going to raise this one up here to the -1. And you can then tell me what is in that spot. So go do that on your calculator. Okay, so what I've done is I've popped that first one, this one. So 1, 1, 1, 2, -1, 3, 1, 2, 1. I did it to the negative power and I ended up with, and I should have got, and I did, I got 7, -1, -4, -1, 0, 1, and down here was -5. So what does X equal? X equals -5. When they ask how many rebounds, that's what R is. So really you just got to solve it and then tell me what the middle number is. So we've already got the inverse hopefully there. So we're going to do this. So you actually just type in this equation. And has anyone done it? Let me do it. Okay, so when I type this into the calculator, knowing that's -5, I get an answer of 19, 10, and 4. So this was points, rebounds, assists. So how many rebounds did he get? He got 10 rebounds. Okay?